With these, we can write the standard form of a parabola when they give us a ton of different information. So
let's practice.
We're gonna practice because one problem may give you one thing and you do it one way, and then the next problem gives you something else. And it's like, whoa, what do I do there?
They didn't give me the vertex.
So it's really helpful to have the charts so that you can look at them, because that's what we're going to be using to help us. So
even your teachers got the charts.
Yeah, we got the charts here. So if the vertex is at 0, 0, look at the chart for 0, 0.
Which is on the left.
Well, not on their note packet, but in your book it would be on the left side.
Yeah.
So if our focus is -3, 0, it has to be y squared equals 4px.
Because we're looking at what's different. Where does the focus show up? Like what value changes, X or Y? And that's your visual cue as to which side to work with.
Yeah, because this is p, 0. So that means that our p is -3, which means, oh look, we just put it in there.
Oh look. If you could draw an equal sign.
Hey, it's your computer. It's not
How
me.
dare you talk bad about baby?
Do you sometimes put your computer in the corner?
When he's naughty.
Okay.
Now how hard was that?
That was not hard at all. So B. Now we've got a focus of 0, -4 and a directrix.
Okay,
at y
I know exactly what to do. Okay. So if the focus is the same distance from the vertex as the directrix is, and we know that the focus has a y-coordinate of -4 and the directrix has a y-coordinate of 4.
Then our vertex has to be in the middle of that.
Then our vertex has to be in the middle.
So that means our vertex is at 0, 0?
Yes, because the x-coordinate won't change on that. The only thing changing is y. And the only thing that's changing is y. I know that because it says y equals 4, and the point has a -4 for the y. Nothing else changes.
Yeah, and so if we look at our chart, that means we're in the first column because we've got 0, something, and we've got y equals something.
Right.
And so from this, we know that p is -4.
Right.
Because the directrix has a negative p, and that makes sense. So our standard form this time is to have x squared equals 4py. So we just need to put in -4. So
x squared equals -16y.
-16y.
I love these kinds of problems. They're just fun. How could you not like this as a mathematician?
I don't know. Vertex is 0, 0. It opens downward, so that tells us which column to look at.
Oh, and it also tells us what p is going to be. P is going to be negative.
Exactly. So, and that's helpful because this focal width is 6.
That's 4p.
And it's the absolute value of 4p.
Right.
And so this could end up being either a positive 3/2 or a negative 3/2, but because they told us it opened downward, we know it needs to be negative.
Yeah. If you open left or down, p is going to be negative.
Yes. So now that we know what p is, and we're in the first column, so we have x squared equals 4 times -3/2 times y, and then we just need to simplify this. That's 4 over 1, so that's going to be -6. And so x squared equals -6y.
And remember, 4p is equal to the focal width. So on this one, they gave us focal width.
Yeah, totally.
Yeah.
So our standard form, by the way, notice that we're not solved for y and we're not solved for x.
No,
and
we're
that
good.
may be a little uncomfortable, but technically for our purposes in this chapter, that is considered standard form.
Right. And if you are one of those kinds of OCD kids and you can't handle it, just divide both sides by -6. It's the same thing.
Yeah.
But you don't have to. Like, you
Right,
don't
just
have to
leave
take
it.
that step.
Just
So
leave
we're
it.
giving you permission to leave it.
All right. So our focus is at -5, 3, and our vertex is at -5, 6. So our x's, well,
The x's don't change. The
The
x's don't change.
x's don't change, but also our vertex is not 0, 0. They
That
told
is
us our
correct.
vertex.
Right.
So we know that we're going to have some kind of a parentheses thing going
Right.
on, right?
Right.
But so the x's didn't change from our focus and our vertex.
So our vertex is
So-
-5, 6. So we just need to figure out if the x coordinate doesn't change, but the y coordinate does. That means that it's got to be opening left or right.
Up or down. The x didn't change.
X didn't change. The y coordinate does, so it opens up or down.
Yes.
That's what I said.
Yeah, totally.
Totally was. So
Look at your
that's
chart
that's
where
a y squared. That's an x squared situation. That's an x squared situation.
Because what's happening here is this is h, comma k plus p. And I know that because this is h. Ooh, that's not an h. This is h comma k. That's our vertex, is h comma k. Our h didn't change, our k did.
Right.
Okay, so that tells us we're in the first column, so this will be an x, this will be a y, and we can fill in our vertex. Go ahead.
X plus 5, super secret opposite society. But a better looking 5.
Yeah.
That's a good 5.
No doubts.
That's a good 5.
And then y.
Minus 6, super secret opposites.
Right. So now we just have to figure out what p is. So
I know.
Yeah.
Well, if the vertex starts at 6 and the focus goes to 3, how far did we move from 6 to 3?
That's a great question. How
3.
far did
We moved 3 units.
Okay. And so it's kind of this situation going on right here, that k is 6 and k plus p is 3, which means you'd fill the 6 in here.
Right, and then you got
subtract,
a little single-step algebra 1 problem.
But it's important that we make sure we get the right sign, right? This
Right.
is p equals -3.
Right, yeah, that's
which
important.
it opens.
Which means it's going to open down now.
Okay,
So.
yeah. I don't know if you mentioned that earlier or not, but. So 4 times -3 makes this -12. And then here we have our focus is 3 comma 4. Our directrix is at y equals 1. If our directrix.
Okay, directrix is a horizontal directrix, which means that it's going to open up or down.
Left
so
or right?
If y equals 1 for the directrix. So if y equals 1 for the directrix.
Oh, I was looking at the axis. You're right. Okay. Sorry. My bad. I was looking at the axis.
Hey, can we just, while this is rolling, could we just get a...
You were right.
Yes.
Okay, let's not make a big deal about it. Okay, so our focus, if we have y equals 1, our focus then has to be h comma k plus p, and our directrix would equal, or is y equals k minus p.
So here's the deal. How far do we go from 4 to 1? That's the question.
3.
So halfway through is where the vertex is going to be.
Okay. And so, and if that is difficult, I mean, you can actually set these equal. Like, I know h has to be 3.
Right.
I know that 4 has to be k plus p. And I know that 1 has to equal k minus p. And then look, you've got this really simple elimination problem.
Two equations with 2 unknowns.
Yeah, so 4 plus 1 is 5. K plus k is 2k. P minus p goes away, so k is, 5 halves.
Which would be 2.5.
Which would be 2.5.
Which is half of 3.
It's
Should be 1.5, right? If you add 2, okay.
Oh, no. Okay, so we're between 1 and 4. Halfway between 1 and 4 is at 2.5 because you go up 1.5 and you go down 1.5.
Oh, that's right. Okay.
Okay, because it's 3 in between there. Okay, so that's why I think the solving the system is a lot easier personally, because it takes the what's going on visually out of it.
Right.
Like this will always work to find us k and p. So if k is 5 halves, you would plug it back in and solve right here. So you'd subtract 5 halves and you'd get that p equals, so 4 minus 2.5 is 1.5, which is 3 halves.
3 halves.
And now we've got h, k, and p, which means we have all the parts we need.
We got all the parts we need.
Which one were we on? Are we in the first column? We are in the first column.
Yeah, I believe so.
So x, h is 3, so x minus 3 squared equals 4 times p, and
4p.
p is 3 halves, so that's
4
6.
4 times,
4 times 3 halves is 6.
Right.
And then y minus k, and k was 5 halves, so minus 5 halves. So you are going to end up with some fractions every now and then, and we've just got to
But you know, it's
get
okay.
over it.
A fraction is not necessarily bad.
No, not necessarily.
Yeah.
Not. It's not like Never mind. All right, our vertex is at -1, -4. That's helpful.
Okay.
It opens to the left. That's helpful.
That's a negative p.
That's a negative p, and also that means we're in the second column. Our focal width is 10.
That's a 4p.
So yeah, the absolute value of 4p equals 10, and so we'll just divide by 4 and get 5/2, but we know it's negative because it opens to the left. If they said opens right, we'd make it positive.
That's
5/2.
correct. That's correct.
Now I've got all our information, so we're in the second column.
We're opening
so
left, right, which means we're squaring the x part.
The y.
The y. Gosh, I don't every time. I even
You,
said it
now
right.
why are you wondering why I doubted you before? So y.
Why would you bring that up?
4 squared equals 4 times p. So 4 times -5/2 is -10.
Yes, because 4 divided by 2 is 2. 2 times 5 is 10.
And then x plus 1, because we add the x part of our vertex.
Right.
There we go.
Bingo,
and
bango,
that was a lot,
bongo.
and you can see how it gets kind of complicated, but we just are having to focus on matching up parts of what we know to parts on the chart.
Right. Right.
So.